Good morning students, I am Snehal from KLE Society's BCA College Nipani. So students, we learned in the previous video about the Quicksort's example. So what we have seen in the theory with respect to that, we try to solve the example on the Quicksort. Now with this video, we are actually trying to develop a program on the Quicksort, and we are going to implement this particular Quicksort program by using the concept of the recursion. So this is the thing which we need to consider with respect to the Quicksort. So just try to implement the program of the Quicksort using the concept of the recursion. So I am trying to open the Turbo C. Okay. Now open the new file, maximize the screen, write the program statement. Now program of sorting using Quicksort through recursion. So this is the program statement. So now we are going to write hash include stdio.h, then hash include conio.h, then we are going to write hash define where max is equal to 30. Now we are going to write the void main. So again we are going to declare one here as enum, numerator enum bool, in the flower bracket we are going to write false, comma, true, and close and the semicolon. So this is the enum variable. Okay, actually we are using the concept of the recursion, means we need to write the program prototype over here, but after later sometimes we are going to add it over in the upper side or in before the main. So with this I am going to write the int arr of max, close the square bracket, then n comma, then I, n comma, okay, I comma n, then printf double quotes slash n. We need to enter the number of elements and semicolon, then the scanf percentage d double quotes complete comma ampersand of n, where we are going to store the size of the array. Then for I is equal to 0, then I is less than n, semicolon, then the I plus plus, and close this, and the closing of the flower brackets. Then the printf statement, enter the mod d element which is equal to double quotes complete comma I plus 1, and close this and the semicolon. Then the scanf percentage d double quotes complete comma ampersand of arr of I, and close this semicolon. Now here We are going to print the unsorted array with the display function. See printf double quotes unsorted array is equal to double quotes complete comma semicolon. I will write the display, then arr, the name of the array, comma 0 comma n minus 1, and close this. Okay, then again I am going to write the printf as double quotes and slash n over here and close this, semicolon. Again I will write one more function as a quick. In parenthesis I will pass the same thing as arr comma 0 comma n minus 1 and the semicolon over here. Again we are going to use the printf statement and slash n, which is particularly used to display the sorted elements and the semicolon. Again we are going to write the display, then arr comma 0 comma n minus 1 and the semicolon. So see, here we are taking the then after that I am writing the get ch. Okay, again I am entering the clr scr, close. Now with this I am going to declare the void display in bracket int array comma int and close. Again void quick in bracket int array comma int and close this and the semicolon. Okay, so after displaying this, again we need to write or move the cursor to the next line. So printf double quote slash n and enter. Now we are going to write the definition for the quick. So void quick in parenthesis int a comma int low comma int up and the close, the flower bracket open and close. So within that we are going to write, see, we are taking the piv as a pivot for the pivot, then one temp variable, then for the left and right and the semicolon. So here we are considering that the enum bool, which is equal to, if I am going to consider that the pivot underscore placed is equal to false and the semicolon. Okay, so left is equal to low semicolon, the right is equal to up and the semicolon. Now if is equal to low, which is the initial value. Okay, take the first element of the sublist as pivot. Now here we are going to check if my low is greater than equal to my up. Okay, with this I need to return. Again I am going to printf, okay, the sublist semicolon. Now again I will give a call to the display function over here. So display with this a comma low comma up and the semicolon. Now the loop till pivot is placed at the proper position in the sublist. We are going to write this particular coding. So while if my pivot is underscore placed, which is exactly equal to FL false, okay, then we are going to consider the floor bracket open and close. So here compare from right to left, so that purpose we are going to use this while loop. While a of p is less than equal to a of right and if my p is not equal to right, then I'm going to write the code as right is equal to right minus 1 and the semicolon. Okay, again if my p is exactly equal to the right, then I'm going to consider the pivot underscore placed, which is equal to true, and the semicolon. So if my a of p, so if my a of p is greater than my a of right and close, then I will write the coding of the interchanging. So temp is equal to temp is equal to ARR, or rather a of p semicolon, then a of p is equal to a of right semicolon, then a of right is equal to temp semicolon, and then we are going to consider that the p is equal to ri right and the semicolon. Now this is the comparison for right to left. Now we are going to write the coding for the comparison from left to right. So we are going to consider that while my a of p is greater than or equal to a of left and my left is not equal to p, then I will write left is equal to left plus 1 semicolon. Then if my p is exactly equal to left, then we need to consider that the pivot underscore list is equal to true, then the semicolon. Now if my a of p is less than the a of left, then we are going to write the code for the interchanging. So we need to consider the temp is equal to a of p semicolon, then a of p is equal to a of left and the semicolon. So A of left is equal to now temp and the semicolon. Now here we are going to consider that the P is equal to left and the semicolon. So this is the thing and the end of the while. So after this we need to consider a one printf statement as, see here, percentage printf C pivot placed is %d, which is equal to A of P and close and the semicolon. With this I am going to display the elements one more time, A comma low comma up and close this. Then with this I am going to display the printf and the semicolon. Okay, now here we need to write the recursive functions again and again to do this. So we are going to call the quick function within this itself again. So here we are going to consider A comma low comma P minus 1 and the semicolon. Again it is for the quick A comma low comma A comma, we can consider the P plus 1 comma up and close this. So here it is the end of the quick function definition. Then we need to write the void display in parenthesis. We can consider the int A comma int low comma int up and close this. Okay, then okay, within this we can consider the int I semicolon. Then here for I is equal to low semicolon, I is less than equal to up semicolon, and then the I plus plus and close this. Now within this I am going to write the printf double quotes the percentage d slash t double quotes complete comma, and here I am displaying the elements of the A of I and close this and the semicolon. So this is the thing which we need to consider. Okay, so here I need to first save this program. So go to the file menu, save your program. Okay, now we'll check. Okay, save, successful. Then run this program. Now I need to enter the number of elements. Okay, then the 48, then the 29, then the 8, then the 59, then the 72, then the 88, then the 42, then the 65, then the 95, then the 19, then the 82, then the 68, so here we got actually the sorted list. but it is displaying very so instead of this we'll take only 10 numbers, or rather 6 numbers only. See, 48, then 29, then the 8, then the 59, then the 72, and then the 88. So here also we got the sorted list, but while displaying so F2, Control C, Alt C, Alt R. So take the 5 elements, C 48, then the 29, then the 8, then the 59, then the 72, like this. Add slash number. So element 1 is 48, then 29, then 8, 59, and 72. Elements 48, then the 29, then the 8, then the 59, then the 72. Okay, now it's correctly displaying to you the list elements. Okay, so this is the actual working of the Quicksort. Now, if you are going to consider the analysis of Quicksort so with this the time requirement of core so the time requirement of the Quicksort is depends on the position of the pivot in the list. Okay, and then how pivot is dividing the list into sublist. It may be equal division, it may be equal division of list, or maybe it will not divide also. Okay, so in average case we assume that the list is equally divided, means the list 1 is equally divided into the two sublists. So these two sublists in the 4 sublists and so on. So we are going to consider the total number of elements at a particular level. It will be 2 raised to 1 minus 1. So the total number of steps will be log to n. So the number of comparisons at any level will be maximum n. Okay, this is the thing. And if you are going to consider the worst case with this, it is nothing but that. Suppose the list of element is already in a sorted order. We find the pivot, then it will be the first element. So here it produces only one sublist, which is on the right side of the first element and starts from the second element. Similarly, other sublist it will be created only at the right side. So the number of comparisons for the first element is n, and the second element it is n minus 1, so which is considered as O of n square. So this is the actual thing which we need to consider with the Quicksort. So this is the Quicksort which we have learned. Now here I want to tell you the one thing, it is that we had finished with the unit 1. As if you are going to see the syllabus of the unit 1, see, I will show you the syllabus of the unit 1. So with this video I want to say you that we finished with the unit 2. So if you are going to check the syllabus of this, see here we have completed all the sorting. See, we seen with the introduction of the data structure, definition and the classification of the data structure, primitive and the non-primitive data structures, then the operations on the data structure. Then we have seen the basic search technique as a sequential search and the binary search with the iterative and the recursive methods. Then we have seen the sorting techniques, the definition, then the different types of a sort such as a bubble sort, selection sort, merge sort, insertion, and the quicksort. So I think that students, here we had end up with our unit 1. So from the next video we are going to start with our unit 2. So till then, thank you students, and do the practice of the programs which we had done within these videos.